Okay, so now let's start the new topic. The topic is axial flow reaction turbine. So why we are saying axial flow reaction turbine? What do you mean by axial flow reaction turbine? So in previous lectures, as we know that axial flow, so we can break it in the parts like axial plus flow plus reaction plus turbine. Means a turbine which is having the flow of water axially. The flow of water axially means if this is a rotating shaft and the water is flowing parallel to the axis of this rotating shaft, so this is axial flow turbine. And what do you mean by reaction? So reaction turbine means, as we all know that we are having kinetic energy plus pressure energy at the inlet of the turbine. So we are saying reaction turbine. So now it's very clear that what is axial flow reaction turbine? That is axial, having the flow axially, and the reaction it is having kinetic energy plus pressure energy. That's a different thing. That now the pressure energy is converted in means the part of kinetic energy, and all comes under axial flow reaction turbine, right? So if you want to define the axial flow reaction turbine accordingly, so if the water flows parallel to the axis of rotation of the shaft, the turbine is known as axial flow turbine, as I told you, right? And if the head at the inlet of the turbine is sum of pressure energy and kinetic energy, as I told you, and during the flow of water to the runner at a part of pressure energy is converted into kinetic energy. Now this turbine is known as reaction turbine, as I told you, right? So for the axial flow reaction turbine, the shaft of the turbine is vertical. Means the shaft of the turbine is vertical. So let's come to describe. Suppose this is a shaft, right? This shaft, and this shaft is placed vertically, right? And now if we make a structure like this, this is connected, this part is connected, means if this is a shaft and this is a part which is connected with the shaft axially, right? Now this portion is known as boss. This portion is known as boss. And the vanes, as we are very familiar, the vanes are connected by the boss, right? So vanes are connected by the boss. So now the lower end of the shaft is made of the larger, which is known as hub or boss. It is also known as hub. It is also known as hub, and as I told you, it is also known as boss. So this is a figure. This I am going to show you. Now this is a shaft. Sorry. These are the vanes which are connected with that particular part. This is known as hub, right? So this is a shaft and these are the vanes which are connected with that particular part, and it's all comes as a part of the axial flow reaction turbine. So the next part, so the important parts of the axial flow turbines. So we can classify in the two types, right? The first one is propeller turbine and second one is kaplan turbine. So what is propeller turbine? First of all, we should know what is propeller turbine. So look in the figure. Suppose this is is a shaft and this is a boss or hub, as we are saying, and now it is having the vanes or blades. So if the blades are fixed, and not adjustable, so I'm very clear with the fact the blades are fixed, and not adjustable. If the blades are fixed and not adjustable, then it is known as propeller turbine, right? And what about the kaplan turbine? The kaplan turbine, the things are even same, means you are having a shaft and you are having a boss as in previous cases, but here we are having the fixed and not adjustable plates, and here in kaplan turbine we are having the blades and the vanes which are adjustable, right? If the vanes are adjustable, then it is known as the kaplan turbine. Clear? So now we can classify the turbine as per the arrangement of the blades. And now the Kaplan is a name of a scientist which is known as V. Kaplan. Now he was an Australian engineer. So right, so let's come to see the main parts of the Kaplan turbine. The first one is scroll casing, the second one is guide vane mechanism, third hub with vanes or the runner of the turbine, and the very important part, draft tube, as I told you in previous lectures. So now I have given the important point that a Kaplan turbine is suitable for low head and large quantity of water available. So we can say the Kaplan turbine is a turbine which is suitable for large availability of water and at low heads, right? So if anybody asks you, so where we use Kaplan turbine, the Kaplan turbine we use where we are having large quantity of water but at low head, right? So let's come, as we have seen the part of the turbine here, so let's come to another part. Yeah, that is a very important part. So if we are having a figure, that is a very important figure of the Kaplan turbine. Okay, so we are having a shaft, right? And the water is flowing in this direction. Water is coming in this direction, and this is a draft tube. So we will see you later. Means after this this discuss the formula that we are having here, that is Q is equal to pi by 4 dO square minus dB square into VF1, right? If you want to discharge through the runner, then we can obtain by the formula, that is Q is equal to pi by 4 dO square minus dB square into VF1. As we know, the Q is equal to A into V. Here this is area, right? And this is a velocity of flow. So we are having this figure, and this figure is a figure of Kaplan turbine. Sorry. So now we are having scroll casing, as it is axial flow turbine. So water flows axially. Look the direction of my pen, and the water comes out from this part. This part is known as draft tube. Here we are having some parts like scroll casing. This is scroll casing, and these are the guide vanes. As we all know, the work of guide vanes, that's vanes which are used for guiding the water, right? And the water comes in this direction. Look the direction of my pen, and come out after doing work over here, and come out from the draft tube. And as we all know, that increasing area of a part which are having some increasing area, a pipe which are having increasing area, is known as the draft tube. So this part is known as boss, as I told you, and having the diameter is dB, and this is the outer part, right? and having the diameter DO, that is the outer vanes, or you may say outlet vanes, and that is the inlet runner vanes. So inlet runner vanes having the diameter D, right, and here we are having that is DO, right? Clear? So this is a figure of Kaplan turbine. Clear? Some important point for the propeller or Kaplan turbine. So these are the important points which will help you to solve the numericals, and once you will see this formula, these are important points, then after this, the next lecture I will provide you how to solve the numerical. As in previous lecture I told you, that is a very common way that we are having the inlet velocity triangle and outlet velocity triangle. The formulas are quite same, and we will solve the numerical accordingly. So here what are the important point related with the Kaplan turbine are as following. That is like, if in the peripheral velocity of inlet and outlet are equal. The peripheral velocity means U1 will be equal to U2, that is pi d nod n by 60. So remember this formula, that is U1 will be equal to U2 will be equal to pi d nod n by 60, where d nod is outer diameter of the runner. Alright, and here the second point, velocity of the flow at inlet and outlet are equal. Vf1 will be equal to Vf2. This relation will help you when you will solve the numericals, and you can solve the numerical with the help of these 3 points only. Clear? Everything remains same as previous cases. Clear? So if anybody asks the area of flow at inlet, then you can find out, because the area of flow at inlet will be equal to area of flow at outlet, so pi by 4 d naught square minus dv square. So remember these 3 formulas. Look at again. U1 will be equal to U2 and pi d naught n by 60. D naught is the outer diameter of the runner. This is for propeller or Kaplan turbine, right? And Vf1 will be equal to Vf2, and the area of flow at inlet will be equal to area of flow at outlet. So in next lecture I will let you know how to solve the numerical. Please go through all my video and just clear your